In 1947, Chuck Yeager became the first person to fly this plane faster than the speed of sound, 768 miles per hour. In 1979, this SR-71 reached a speed of almost 2,200 miles per hour. And in 2004, this unmanned NASA X-43A went over 7,500 miles per hour. What? That, as a rocket scientist would say, is a lot of thrust. Thrust is a force that pushes an airplane or rocket forward. So really, that's a lot of force.
Don't underestimate the Force.
The Force is what gives the Jedi his power. It's an energy field created by all living things. It surrounds us and penetrates us. It binds the galaxy together.
Not what I'm talking about. Scientifically speaking, force is a push or pull on an object that is caused by its interaction with another object. Or as super famous dead scientist guy Isaac Newton would say,
force equals mass times acceleration.
That is actually Isaac Newton's second law of motion, and it is super handy. It tells us that there is a relationship between how big something is, how fast it's going, and how much force it has. It makes a lot of sense, really. The bigger something is, the more force it takes to get it moving quickly. Let's time out here for a second. We need to talk for a minute about mass. Mass is a measure of how much stuff something is made of. Mass is not the same as weight. If I have a mass of 55 kilograms right here on Earth, I will still have 55 kilograms of mass on Mars, or the Moon, or the space station. Mass doesn't change no matter where you are. Your weight does change. I would weigh less on Mars, even less than that on the Moon, and nothing on the space station. That's because weight is measuring how your mass is affected by gravity. But we'll get back to that. Since force, mass, and acceleration are all related, you can use any two of them to figure out the other one. But how do you measure force? Like, in units of boom?
That's not how the Force works.
Nope, in newtons. Because this guy.
Interesting.
So, if this airplane has a mass of 2,000 kilograms, and we need it to go 100 meters per second squared, that requires 200,000 newtons of force.
Use the Force, Luke.
If we add more mass to the plane, we'll need more force to get the same acceleration. If we keep the mass the same, but add more force, it will make the plane accelerate faster. It's all related. Pretty simple, right? Not exactly rocket science. But let's go back to that mass and weight thing. Remember I said that weight is measuring how your mass is affected by gravity? Well, put another way, your weight is a measure of how much force your mass is applying to the ground. Your weight is mass times the acceleration of gravity. So, how much do I weigh, really? Well, the acceleration of gravity is 9.8 meters per second squared. Thanks, guy.
Interesting.
Multiply that by my mass, 55 kilograms, and you get 539 newtons. That's a lot of newtons. Well, maybe not that many newtons. It's a good number of newtons.